Are there any questions on any of the assignments thus far? Any questions on any of the homework assignments? All right. All right, guys. What we're talking about today, the first thing we're talking about today is the fundamental theorem of algebra. For the trivia? The trivia question? I'll search it up online when I get home. All right, guys, so the first thing we're looking at today is the fundamental theorem of algebra. And it is displayed in this here. So our first equation that they gave us is 2x minus 1 is equal to 0. Well, the degree for this equation is 1 because 2x is the only term with variables, and x is to the first power. So the degree is 1. Now the solution for this here would be 1/2, which gives us a grand total of one solution. There's only one number that is the solution for this here. Now the second equation is x squared minus 2 is equal to 0. So the degree would be 2. The solutions for this are plus or minus the square root of 2, which gives us a total of 2 solutions. Our third equation is x cubed minus 8. Well, the degree for this is 3. The solutions for this here are 2 and negative 1 plus or minus I squared of 3, which is 3. And our last one, x cubed plus x squared minus x minus 1 is equal to 0, is a degree 3, which has solutions of negative 1, and 1, which if we count the repeated term, and we will, gives us a total of 3 solutions. Now, if we notice this here, the degree of the polynomial function and the numbers of solutions are the exact same. And that really is what part of the fundamental theorem of algebra states. Now, the theorem itself states if a polynomial function of degree n, where n is greater than 0, then the equation f of x equals 0 has at least one solution in the set of complex numbers. And really, for any solution like x equals 4, we can write as a complex number by just adding 0i. Now it's a complex number. That's all that's really saying. It's either going to have I as an answer, or we can really add it like this here. Now the corollary, what comes from this theorem, if a polynomial of degree n, where n is greater than 0, then the equation f of x equals 0 has exactly n solution, provided each repeated solution twice is counted twice. Or if it's repeated 3 times, it's counted 3 times. So the degree will tell us how many solutions each polynomial function will have. So if we look at this first example here, how many solutions does the equation x cubed plus 3x squared plus 16x plus 48 equals 0 have? 3. And it actually works out that the solutions are going to be negative 3, 4i, and negative 4i. So the total solutions would be 3. How many solutions would this one have? Because? And if we found them, the solutions would be negative 2, negative 2, negative 2, and 0. We ended up getting negative 2 3 times. So the number of solutions for this equation would be So the number of solutions would be 5, but we do need to find them this time. So finding them here. So 5 is the total number we need. We need to get to 5. But the main that we can find them is by doing what first? We can graph it, because if I can graph this function, then it'll tell me at least some of the zeros. Now, how many am I hoping to get by graphing? 5 would be great, but how many do we need at least? 3. Because if I find 2, well, that would take it from, using synthetic division, take it from a degree 5 to a degree 4. The second one, take it from a 4 to a 3. But we need a third one to take it from a 3 to a 2. Because if it's a quadratic, then we can use our methods for solving quadratics to get it from there. So we could pull up the graphing calculator and hit y equals. And we can type this in, x to the 5th. So I'll clear that out, x to the 5th plus x to the 3rd minus 2x squared minus 12x minus 8. So we want to get this typed in, and once we get it typed in, we hit graph. And we get this graph here. We all get the same graph, or something similar to this here. Huh, error. So go up to the plot and hit enter. Now hit graph. If any of those stat plots are blacked out, so I'll turn this on. So if when you're graphing, if you see one of the plots darkened around it, essentially plot is in white, you'll want to turn that off by going up, selecting it, and hitting enter. Because those stat plots are numbers where we can graph individual points. If it's turned on, it's going to cause errors or cause some issues. Now, when we look at this here, we do see 2 zeros. One of them looks like to be at -1 and the other is at 2. Now, we talked about this a few times. Whenever the graph touches the x-axis but doesn't cross it, it has an even multiplicity. So the numbers of zeros at that point is going to be an even amount. So we'd have 2, 4, 6, 8 going up. If it crosses it, it has an odd multiplicity. For the most part, that means it's going to be kind of 1. But it could be 3, 5, 7, 9, and going on like that. So the one we saw earlier where we had -2 repeated 3 times, it would just cross. It has 3 at that location, but it will just look like this here at 2. It's just going to cross that graph. So, coming back over here, we know that x is equal to -1 and 2, and possibly what else? -1, because the graph just touches there. So we'll see. And we'll set up our synthetic division. So we can do -1 first. Then we would have 1 for x to the 5th, followed by 0, because we don't have an x to the 4th, so we need to put 0 in its place. 1 for x cubed, -2 for x squared, for x, and -8. And then we'd bring down the 1. And now we do our synthetic division. So -1 times 1 is -1. Add straight down. 0 plus -1 is -1. -1 times -1 is 1. 1 plus 1 is 2. -1 times 2 is -2. -2 plus -2 is -4. -1 times -4 is 4. -12 plus 4 is -8. And -1 times -8 is +8. And -8 plus 8 is 0. And that would be our remainder. And did we expect to get 0? Well, yes, because anytime we have a remainder of 0, it means it is a solution. And we do know that -1 is a solution. What number can we do next? 2. Because we could have done 2 or -1. Either one will work. Yes. All right. So let's look at this here. So we would do 2 times 1, which is, okay, if it'll write, 2. -1 plus 2 is 1. 1 times 2 is 2. 2 plus 2 is 2 times 4 gives us 8. -4 plus 8 is 2 times 4 is, and -8 plus 8 is 0, which is exactly what we wanted. Now we definitely need to do this one more time because we're only at a degree 3. We need it down to a degree 2. So what other number can we try? -1. As we looked at the graph, -1, did it actually cross at that point? Well, no. So that means it has an even multiplicity. So -1 times 1 is -1. 1 plus -1 is 0 times -1 is 4 plus 0 is -1 times 4 is, and 4 plus -4 is 0. So this here is our remainder. So that does finally get us down to a degree 2, like we wanted. So we can plug the variables back in. 4 would be our constant term, 0 would be with x, and 1 would be with x squared. Which really tells us that our final equation, or what we're working with now, is x squared plus 4 is equal to 0. Now, because it doesn't have a middle term, we can use the square root method, which we would do what first? -4 from both sides, telling us that x squared is equal to, and then we would square root both sides. Square root of x squared would be x is equal to, because whenever we square root both sides, we need the plus or minus. Now we need to take square root of -4. 2. All right. Because anytime we take the square root of a negative number, the negative will come out as I, and then we can take the square root of the number itself. And what were our 2 other solutions, or 3? -1, 2. So -1, -1, and 2. No. As long as we have all 5 listed. And that is it. That's all we have to do for this year. Now, we would use the rational zeros theorem like we did the other day with the plus or minus p over q. I would revert to that if, when we went to solve it, we didn't get enough whole number solutions, because the rational zeros really helps us with the fractions, seeing which fractional answers could be possible. Any other questions on this here? Yes. I got them from Quill. Quill is a kind of Office Max or Office Depot kind of store. The light covers. Yeah, to make it a little bit better, they make these for this particularly because the 4 corners and in the middle are actually magnets to hold them to the ceiling. It would have. Let's look at this next one here. So, how many solutions do we expect to find? Because the degree is 3. So we're going to go on and graph it to find solutions. How many solutions would be nice to find? 3, because it'd be nice to find 3, because if we find 3, we are done. We need at least 1. Because if we have 1, we can take it from a degree 3 to a degree 2. If we have 2, that'd be even better. And if we had all 3, that would be the best outcome. So let's go on and plug it into the graphing calculator and see how many zeros it gives us. So when you say y equals, we can clear this out. X to the third plus 7x squared plus 16x plus 12. And if we graph it, so we do get 2 points. If we go second graph, we can see here at -3, the y value is 0, and at -2, the y value is 0. So it did give us 2, possibly 3, because if one of these repeated, then we would have the third. We can come back over here and use the synthetic division. -2 and -3. Jalen, which one do you want to use first? -2 or -3? -2. So we'll put it in the cubby hole. Going across the top, we would have 1 for x cubed, 7 for x squared, 16 for x, and 12. We can bring down the 1. -2 times 1 is -2. 7 plus -2 is 5. -2 times 5 is negative. 16 plus -10 is -2 times 6 is negative. And 12 plus -12 is 0. Now we could stop at this point here and use the quadratic formula to solve, but we do have another solution, so why not use it? So our other number is -3. Actually, let's try -2. Okay. Let's try -2 and see what we get. Well, -2 times 1 is 5 plus -2 is just going to be 3. -2 times 3 is, and 6 plus -6 is, since we got 0, that means it is a solution. Now we can do -3 here. -3 times 1 is 3 plus -3 is. So this is a remainder. Whenever we're left with a constant as the last number, we're done. It's been doing that the last few days, and I don't know why. Yeah, but it's been switching colors on me.
Two different colors.
So the solutions are x is equal to -2, -2, and -3. Because, yes. Okay. And if we look at the graph, it's kind of hard to see. At -2, because the graph did go above it and came back down and went back up, it actually never crossed at -2. So we would have 2 solutions there. Any questions on any of these here? Do you want to see one more of these? So we can do this one here. So this one here we should have 5. If we get all 5, that'd be great, because then we wouldn't have to do any other calculations after it. But at least we need to get how many? 3. We're going to find all of them, but with graphing we hope to get 3. So we can pull up the graphing calculator. So we can clear this out and put in x to the 5th minus 3x to the 4th plus 5x to the 3rd minus x squared minus 6x plus 4. And once we get it typed in, we can hit graph. So how many zeros did it give us? Because it does intersect the graph at 2 points. We have -1 and 1, yes? Does it cross at 1? Does it actually cross the graph at 1? No. It doesn't actually cross at 1, so that means that it has an even multiplicity. Because if it doesn't actually cross, that means there's more than 1 0 at that point.
I feel like if you watch TikTok, you think everything on there is dumb. Wait, actually, there's some smart people on TikTok. So
Why don't you coach or teach it like college? Because like you're really smart.
I like it here.
He likes teaching a whole bunch. That makes fun of us. We love it so much too. I love this place. I wake up every morning.
I know.
Prepared to come to this place.
Well, not the place.
I just don't like the class.
This. I like this class. Sometimes it's too fun. I'm just talking about making fun of Caleb. No.
This is probably one of my like favorite classes. What?
Come on. There we go.
He's so smart.
Yeah, I was like trying to figure out why I wrote -1 twice. Because 1 for x to the 5th, -3 for x to the 4th, 5 for x cubed, -1 for x squared. Then it would be 6 and 4.
But you should know that, so that you got a degree.
Yes. All right, so let's go on and do the multiplication. -1 times 1 is -1. -3 plus -1 is -4. -1 times -4 is 4. 5 plus 4 is? -1 times 9 is? -10. -1 times -10 is? 10. -6 plus 10 is +4. -1 times +4 is? It is 0, which would be our remainder. Exactly. So what number can we use next?
What is that?
Yeah, I didn't pick the pen up.
He's just so smart and so fast that he forgets to do it.
Yep.
I do it all the
Were you
time.
the smartest kid in class?
I was not.
You want an honors graduate? Graduated with like 500 people.
Yeah.
Where at?
At Hendersonville.
Who was the smartest? Was it a boy or a girl?
I don't know.
He was party animal. Rock and roll, baby. He was. We went to the wine.
Every now and then.
Look.
So
Are you gonna
I was in the top 10%.
See, on the English and English part, I fell off.
Yes. English, yes. So let's multiply through by -1. -1 times 1 would be? And then we add together, you get -5.
Dude, I'm a champ.
Negative 1 times negative 5 would be 5. 9 plus 5 is?
See, I got that quick now.
Negative 1 times 14 is? Negative 14. Something. Yes, because that should be getting us. Yeah.
I would sit at the dinner table all night till it's dark and not fall asleep. Like 3 days a week.
24. So is negative 1 a solution? No. Because what was our other two numbers? 1 and 1. All right, guys, so let's try this again with 1 instead of negative 1. So 1 times 1 would give us 1. Negative 4 plus 1 is 3. 1 times negative 3 is negative 3. 9 plus negative 3 is 6. 1 times 6 is negative 10 plus 6 is negative. Negative 1, or 1 times negative 4 is negative 4, which is 0. Yeah, so when we did the negative 1 the second time, it didn't work because negative 1 only showed up once. I accidentally wrote negative 1 again. And last but not least, we're going to try this, do this again with 1. And we'll multiply again with 1. 1 times 1 gives us 1. Negative 3 plus 1 is 1 times negative 2 is negative 2. 6 plus negative 2 is 4. 1 times 4 is. And negative 4 plus 4 is 0, which gives us our remainder. Hopefully it doesn't pick up the eraser again, because now we can plug in the variables x and x squared. I did change it to blue. So the final equation that we have left to work with is x squared minus 2x plus 4 is equal to 0. Now, since we do have a middle term, we're going to need to use the quadratic equation. So x is going to equal negative b plus or minus the square root of b squared minus 4ac all over 2a. Because we do have a middle term for negative 2x. On all the ones we did previously, we just had the x squared and a constant. We didn't have a number with x. So we could use the square root method. But since this does have the negative 2x, we'll have to use the quadratic formula. And we just need to plug in for a, b, and c. So the first thing that we have in the quadratic formula is the negative b. Well, what is the value of b for this equation here? Negative 2. So negative 2 would be just positive 2. Plus or minus the square root. So b squared would be negative 2 squared minus 4 times a. Well, a is 1 times c is 4. All over 2a, 2 times 1, which gives us 2. X is equal to 2 plus or minus. Now at this point here, highlighter, I would plug everything that's inside the square root into the calculator first. I wouldn't use the square root, just in case it doesn't simplify, or it turns out to be a negative. In this case, it actually works out to be negative 12. Guys, let's focus in. So we need to simplify the square root of negative 12. Now the negative will come out as I, which leaves us with the square root of 12. Now the TI-30XS, the yellow calculators, will take the square root of 12 and simplify it and tell us that it is 2 square root of 3. Any questions on how we got to this point here? Yes. Thank you. Probably at home.
Oh, Christmas
Now,
tree,
because the top two numbers are both divisible by 2, because 2 and 2i are both divisible by 2, we can divide them both by 2, which will give us 1 plus or minus I square root of 3. And then we would have 1, 1, and negative 1. No.
Aren't we one of your best bets? Like, well, I'm saying like we don't really actually talk all that much. Like compared to that. Oh yeah. Right. You know. Yeah. I like it. You guys better be careful from Finn. He's gonna get y'all. I was scared.
Any questions on this here? Okay.